The first step in calculating the standard deviation is to get the difference between the average and each observation. In the formula, we subtract the average from the observation. The observation is 2, subtract 5, we get minus 3. The observation of 3 minus 5 is equal to minus 2, 6 minus 5 is equal to 1, and 9 minus 5 is equal to 4. Each difference is then squared, so that minus 3 squared is equal to 9. Minus 2 squared is equal to 4. 1 squared is equal to 1, and 4 squared is equal to 16. The next part of the formula is to add up the squared differences. Here we can use the sum function from the menu, and the sum of the squared differences is equal to 30. To find the variance, we divide the sum of the squared differences by n minus 1. N is 4, so we divide the 30 by 3, n minus 1. And if we can get it, so that the variance is 10. The variance is in the units of the sample squared. So for example, if these were observations in feet, 2 feet, 3 feet, 6 feet, and 9 feet, then the variance is in feet squared, which is kind of useless. Getting the standard deviation, though, we take the square root of the variance, which is 3.16. This is 3.16 feet, the same units as the observations in the sample and as the sample average. Another thing to notice is that the standard deviation is always positive. We've calculated the difference between the observation and the average, which could give us a negative number, but then each number is squared. We add those up and divide by n minus 1, so we have 3.16 positive. We can never have a negative variance or a negative standard deviation. The important thing to note is that observations further from the average have more influence than those close to the average. For example, the observation 6 is 1 unit away from the average. 1 squared gives us 1. The observation 9 is 4 units away from the average. Squared is 16. So that the observation 9 has 4 times the influence on the variance as does the observation 3. Of course, we take the square root later on, so that the 9 in terms of the standard deviation is twice as important as the observation 3.